Assalamualaikum dan selamat sejahtera. My name is Zulaikha binti Abdullah. I'm a lecturer from Jabatan Kejuruteraan Mekanikal in Polytechnic Muka. Today, I want to present about my title of research, which is Development of All Pump Shell Reinforced 316L Stainless Steel Composite prepared by Powder Metallurgy route. Introduction. So, MMCs, which is metal-metric composites, are a combination of two phases, which are metric phase and reinforcement phase. The main advantage of MMCs are high strength and stiffness, low thermal stress, electric conductivity, and wear resistant. So, basically, metal-metric composite can be divided into three. So in this research, I will choose to produce particle reinforced MMCs. Okay, this is for the experimental method for my research discussion sections. So as you can see here, this is the 55% stainless steel samples. So the figure A is the sample before sintering and figure B is the sample after sintering. So before sintering, we can see the shiny surface at the sample. This is due to the powder of stainless steels, and we can see the crack happens at the samples here. This is due to the pump shells granules is different size and shape with the stainless steel. It's a different shape, different size. Where after we mix them together, is tend to cracks. Okay. However, after the sintering process, we can see the porosity in the surface. After sintering process, the crack is can be eliminated and the sample actually retain the cylindrical shape while the porosity shows in the surface. So the porosity is a present of burn OPS. Because of the burn of OPS, make the sample is porous. So the sample is darkened to black in color and little distortion can be seen on the sample shape as seen in figure. So the upper surface of the sample is melted at the temperature 1150 degrees Celsius. Okay, next we increase the stainless steel content into the mixture, which is 68%. So same from the previous samples. Figure C is before sintering and figure D is after sintering. Okay, before sintering also same with a shiny surface gray and a little crack happen here due to the different size between all pump shells and uh, stainless steels. So after the sintering process, the sample as we can see in the figure D, the sample still maintain the cylindrical shape with the porosities formed into the surface of the sample. We can see the porosity here. So from the result, it is shown that a large pore on the surface while having melted stainless steel solid. So the sample is still in solid, in melted solid, but having a porosity in their body. So with shiny silver surface. Okay, in my research, I used tube furnace, which we know tube furnace using argon gas to supply to the sintering process. So this sample is behind, the location of the sample is near to the argon gas supply to the uh, tube furnace. Okay. So it's tend to protect the argon gas tend to protect the sample from the oxidation happen. So if the oxidation happen, usually the sample will be in a black color. But if the oxidation not occurs, so the sample will be in shining silver. Okay. So the next sample is we increase the another 5% of stainless steel. So in this sample, we can see happen cracks. So whenever we increase the stainless steel content, so the crack happen uh, more and more. Okay, we can see at this picture the crack, we can see it clearly compared to the previous samples. Okay, then uh, also, we can see the sample before the sintering is grayish, and after the sintering, the sample is darkened into black color. Okay, the location of the sample during the sintering is far from the argon gas. So this sample is tend to expose for oxygens. So sample in figure F is slightly larger pores. So we can see the larger pores and the cylindrical shape is still visible. Okay, the shape is still visible but it's not as perfect from the previous sample. Okay, so the surface is mostly melted into solid stainless steel as we can see in the figure. So for the next sample is 78% stainless steel content in the mixture. Okay. Also, same with the previous samples. Before sintering, the sample is cracked and the color is gray due to the stainless steel powder color. Okay. So after sinter, it's hard to see the cylindrical shape because the stainless steel weight percent is increasing. So but we can see the large porosity in the body. This is due to the burn OPS in it. Okay, so both samples are darkened to black color after sintering and were completely hardened. So the sample actually darkened to black color is due to oxidation. And next one is a 75% stainless steel samples. Okay, this is the highest content of stainless steel powder in my research. So we can see that also have a crack in the green body before sintering, but after sintering we can't see the crack. Okay, the sample is fully solidified. Okay. So from figure, the sample has darkened into black color, also dark into the black color while having a small pores. Okay, compared to the previous sample, these samples have a little or small pores. Okay, so the shape has distort but still visibly show the cylindrical shape of pre-sintering. So we have a defect or distortion happens in the samples, but physically we can see the samples still have a cylindrical shape. Okay, the sample show more porosity while having a shiny silver surface, had a solidified and show melted stainless steel at the upper surface of the samples. Okay, then when we touch the surface using our hands, so we can see that the surface is hard. So it can be proved that the samples is fully solidified. So this is the result or the graph for the shrinkage average in my research during shrinkage evaluations. So we're using a formulas to calculate the shrinkage by height before and after we sinter. So higher value of each sample is shown by 55 weight% at 44.63 shrinkage, while the lowest is shown by 75 weight% at 25.1% shrinkage. So the highest shrinkage is shown by 55% with the 38.21 shrinkage. Overall, 55% show the highest potential for further study since it show the highest porosity and the best retaining their shape after the sintering process happens. So, 55% or lower is suitable to be sintered in temperature 1150 degrees C in tube furnace. So lastly, for the conclusion, after sintering, the best result was shown by 55% stainless steel samples as a porosity are present and their ability to maintain the cylindrical shape of the compacted samples. So 55% show the highest potential for further study as it show the highest porosity and the best ability to retain the original green samples. So the height change post-sintering was decreasing as the stainless steel content is increasing. So the shrinkage percentage are decreasing as the stainless steel content is increasing, which show that the highest the OPS content, the lower the height change after sintering. The change in color was due to the oxidation during sintering of the samples.